All right, this is section 1-2, irrational numbers. And what we did on these notes is we made a table with listing the first 15 numbers and 15 counting numbers, and then we found their squares. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and so on and so forth. 12 times 12 is 144, all the way up to 15, and 15 squared is 225. So this bottom row, those are all the perfect squares. The top row, those would be the square roots for the perfect square. And you have to know the whole bottom row. So if I give you 8, you know that's 64. If I say 15, you know the square is 225. And vice versa. If I give you 225, you know the square root is 15. So you need to know these, but you should really already know up to 12, so it's just the last 3. Now, a perfect square, I'm going to give you a math definition here. Is defined like this. It's a number that has a whole square root. And as you see up here, 64 is a perfect square because its square root is the whole number 8. When you write this definition, it goes like, you have a parenthesis, squared equals a perfect square So some number squared is a perfect square if what's being squared is a whole number. So if this is a whole number, like 10, 10 squared is 100, and 100 is a perfect square. Or I could have 4 in here, or 2 in here, I'm sorry, 4 wouldn't. I could have 2 in here, and 2 squared is 4, and 4 would be a perfect square. So this number that's inside here that I'm squaring, this is your square root. So it's kind of a mathy way to write this definition. Now, let's do some examples of that to help it make a little more sense. Slide that up. Sorry, it's hard for me to write. I have to write sideways a little bit under this camera. So examples. 4 is a perfect square. Because I can go like this. There is some whole number that I can square to get 4. And that would be 2. So 2 is the square root of 4, and 4 is a perfect square. Now the reason they call it a perfect square is because there exists a square that has an area of 4, and the side lengths are going to be whole numbers. In this case, 2 and 2. Right, because the area of a square is just one side times the other side. It's length times width, but those are both the same number. So the perfect square is the area, and then the square roots would be the side lengths. Now there's one more square root for 4, and this one's kind of weird because you don't think about it, but there is some other number times itself that gives you 4. And that's going to be a -2, because -2 times -2 makes a +4. 2 negatives make a positive. Now let's do 9. Right, 9 is a perfect square. So I can write it like this. There must be some whole number that squared makes 9. Well, that's going to be a 3. And 3 would be the square root of 9. And I could also make a square that has an area of 9. That will have whole number side lengths. So the side lengths would be 3, because the area is 3 times 3, which makes 9. The other square root for 9 would be a negative 3. Now, the important part of this is that numbers have a positive and negative square root. Numbers have a positive and a negative square root, but we need to say positive numbers, and we'll see why. Positive numbers have a positive and negative square root. Now, if that's still not making much sense, then I think it will once we do the examples here. So example 1. One way this section can ask a question, or in your homework, one way that you might see a question asked would be, what are the square roots of, and notice that's plural, then it'll give you a number, 25 for example. Well, 25 has a square root. That's a perfect square. It has a square root of 5, but it also has a square root of negative 5, because I can square both of them and get a positive 25. So this would be your answer. If they give you a fraction, 81 over 100, you do it almost the same way, but you look at the numerator separately from the denominator. So the square root, so what I'm doing when I find the square roots, I'm taking the square root of 81, which is 9, and the square root of 100, which is 10, and then that makes the fraction 9/10, but you need the negative one too. And let's do one more like that. 1/9. I want the square roots. So I take the square root of the top, which is square root of 1 is 1. The square root of 9 is 3. So I get 1/3 is the square root, but also negative 1/3. So that's one way. They ask you for the square roots using words like this. Then you'll have two roots, a positive and a negative root. Example 2. This type of problem will use the symbol. So the square root of 64 using a square root symbol. And that equals 8. So 64 is the perfect square. Its square root is 8. But don't put negative 8 in this case, because this symbol means only the non-negative, and by non-negative I mean positive or 0, only the non-negative root Just give the positive one in most cases, unless it's 0 and just 0. Okay, let's call that A. Let's do a B. So the square root of 49 over 144. You're just going to do this. You're going to take the square root of the top and the square root of the bottom separately. And I get 7/12. But you don't want the negative 7/12. Only give the positive one. So here's your answer. And this was your answer for the first one. Example 3, different type of problem. Different case, I should say. The square root of a negative number does not exist. And that's what you would put, does not exist. Or you could say not possible, or even imaginary. And that's because there's no number times itself that can equal a negative 36. Negative 6 times negative 6 would make a positive 36, so that doesn't work. 6 times 6 makes positive 36. And you can't have negative 6 times positive 6 because you're not multiplying a number by itself. Those are two different numbers. And example 4. Still on the paper? Yes. If I take a square root and then I square it, well, if you try to do this, if you just do the inside first, which would be the square root of 4 is 2, and then you square 2, I get the 4 back out. That equals 4. Or I write it the other direction, 1.8 squared, and then on the outside I have the square root. Same thing. If I square a number and then I take the square root, I get the number back out. So the square root and the square cancel each other out. They undo each other, kind of like division can undo multiplication when you're solving equations. Let's see, how are we on time? 7, I have 6 minutes. I think I can do the next kind. Okay, this next section, it's still part of section 1-2, but they're different kind of problems. Estimating square roots. With practice, these will make more sense. So you're going to be, I think before I do it, let me list out the perfect squares. I'm going to list let me list the first 10 or 12. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and just for kicks, let's do 169. It's helpful to have this in front of you when you do these. Example 1 is the square root of 5. We want to estimate this square root between two integers because this is not a perfect square. It does have a square root, it just happens to be an irrational number. So you want to locate on the list of perfect squares, locate where 5 would fall, so it's going to be between 4 and 9. And we're going to write an inequality that sandwiches our square root between two perfect squares. So the square root of 5 is between the square root of 4 and the square root of 9. So that's the first thing. You actually have to write this step out. And let me get a highlighter so I make sure. I want to see this written down. It's one of your steps. Then you're just going to find the square roots of these two endpoints. That's 2. This we can't do anything with yet. This is 3. So the square root of 5 is between 2 and 3. So we've narrowed down the location a little bit, but we want to get even more precise. So you're going to draw a little piece of the number line that has the 2 and the 3 on it. 0 would be down here, but we don't need to put anything else. Make a halfway point. And then we're going to plot our point either on the left half or the right half, closer to the 2 or closer to the 3. So go back and look at your original inequality, and you have to ask yourself, is 5 closer to 4 or 9? It's closer to 4. That means its square root is going to be closer to 2. So somewhere in the left half, you're going to put your point. This is where the square root of 5 is. So the third thing you're going to show me is this line right here. 3 minutes left. Okay, let's do a quick negative example. So negative, let me do a bigger one. Negative square root of 110. So find out where 110 would go just on your positive list of perfect squares. It's going to be between the 100 and the 121. So when I write my inequality, all you have to do, this is what makes this problem different from the other one, the negative. You have to watch out for this first statement. If these numbers are negative, then 121 is actually a smaller number when it's negative, and 100 is a bigger number. So I need to put negative square root 100 as the bigger number and negative square root of 121 as the smaller. You switch these two, the two that are around your number. You've got to reverse the order because on a number line, the bigger negative number, the bigger absolute value as a negative is actually smaller. So then this is negative 11, negative 110, and this is negative 10. So our square root is going to be between negative 11, negative 10. Remember, negative 10 is actually bigger. 0 would be up here somewhere on this side. Make a halfway point between these two and go back and look at your number. Is 110 closer to 100 or to 121? Well, it's 10 away from 100, but it's 11 away from 121, so it's slightly closer to the negative 10. So I'm going to put it maybe like that, and then label it. And so you're going to show me this, this, and this. And there you go.